Now we are going through worked example 4. Let's see what it says. The histogram below shows the distribution of the weights of 160 graduates from the engineering department of a particular university. All the rectangles have been drawn, but the vertical scale is missing. So here there's an N here, have been drawn, but the vertical scale is missing. Wow. So they've given us histogram. Huh? The histogram. Here is a histogram with all these bars. And they've given us a missing vertical scale. They haven't given us the frequency density. So they've given us only the weights. The vertical scale is missing. Wow. So what do they want us to find? That's a nice type of a question. Compile a grouped frequency table. Frequency table, we know what a frequency table is. That's the frequency distribution, right? For the distribution. We can have a table as a frequency distribution. So we know what it is. We need to know the weight and we need to know the frequency. Then we can make that table. So in other words, we are to find the frequencies. Now, how do we find the frequencies? We need to know the frequency densities. Then we can be able to find the frequencies. How do we find frequency density? Frequency density, we know there is one formula for histograms, which we have to know, which we won't be given, is frequency. Frequency density is frequency over the width. We've talked about it so much, right? Now, what are we looking for? We are looking for the frequency, which means we take width to the other side. We would say frequency density times width of the class should give you the frequency of that class. So if you know the frequency density and you multiply by the width, then you can get the frequency. So I want the frequency. So I should know frequency density and width. But the problem is frequency density is not there. Okay, it's not there. So what am I going to do? I'm going to need to get it. What am I going to do? Well, I'm going to do this. I'm going to call my frequency density. I come here. You know that frequency density starts at 0, right? Now, I'm going to imagine that one bar is going to be called H, okay? Which means this would be 2H, 3H, 4H. This would be 5H. Then this would be 10H. So I'm only going to put the 10s, right? I know that this is 0. And here this would be 10H. Then this would be 20H. Then this would be 30H. Then this would be 40H. Then... let's see, the next one would be 50H, then this last one would be 60H, right? There we go. So I have them. I'll call them H's. Then I can be able to work like that, right? Then now I can be able to find to give an estimate. Say I have 30 to 40, I would multiply it by 20H, then I know the frequency. But I still don't know what H is. Now, there is a trick that we can use to then find what is H or what H is. We've already called it H. Now there is a trick we can use, and that is to go to this statement here, which has given us the total. It has given us that we have 160 graduates in total. That is the total frequency. Total frequency is 160 graduates. And what is the total frequency? It is the area of all the bars, because frequency is, remember, to get frequency, I say frequency density times width. So in other words, to get the frequency to get frequency of 30 to 40 here is going to be the area of this bar, of the 30 to 40 bar, which is going to be the width, 30 to 40. The width would be 40 minus 30, that would be 10, times the frequency density, which is 20H. Then I'll get this as 200H. That's the area, which means that is the frequency of this first bar. Then the frequency of the next bar, I'll get the area. I add all the areas, then I can be able to get the total frequency, which I know my total frequency would be 160. So I know that this was 200H from saying 10 times 20H, right? Then I got, so I want to do the same for every bar and add them. So I'm going to say, here is my part I. Let's do. We want to find the frequency table. We want to find the frequencies. We want to be able to know them. And for us to be able to know them, we need to know what H is, because I know my frequency is 200H, but I need to know what the H is. So let's go ahead. I'm going to say that total frequency. I know the total frequency. So I'm going to say that total frequency of histogram what is it going to be equal to? It's going to be the total area, right? Total frequency of histogram is the total area of the histogram. So remember what we have done. We've coded each box H. Do that part. And now we have some frequency density scale, but it's in terms of H. Then now we can be able to use the total frequency and find what we need, right? It's going to be adding the areas. We add the areas. It's going to be, we add the areas of all of them. So it's going to be, the first one is, area is going to be what? The width, 30 to 40, which is 10. Okay, you say 40 minus 30, you get 10 times. You multiply by the frequency density, which is the height, right? That's going to be 20H for the first one. 10 times 20H. We'll get the area of the first bar. Plus area of the second bar. What is it going to be? I first look at the width. 40 to what? Oh, the year it is a 55 because they normally give us tens. So here we should put 65 to 55 so that we know. They won't give us. We will put it. So I know that this is 55 because that is between 50 and 60. Okay. So it's a 55. So now I say 40 to 55. How much is that? I'll say 55 minus 40. I'm going to get 15. So my width is 15 multiplied by the frequency density, the height, which is 30H. You can see that it's 30H for this second column right here. This guy, I can see that 30H is the height. Okay. Then now we can go to the next one, which is this guy here. What is he? He is from 55 to 60. 55 to 60, that is 5, right? So you say 60 minus 55, you get 5. So you say plus, in here it will be 5 times, what is the height? 20H. Then plus the next one is going to be 60 to 65, which is 5 again, times, what is the height? We are on this bar now. What is the height of him? He is 40H. Okay, so we are going to call this 40H. So it'll be times 5 times 40H. Then we go to the next one, plus the next one is going to be what? 65 to 70, this guy. And we can see that he is 5 as well. 5 times the height is going to be, what is the height there? 30H. 30H. Plus, let's do the last one. 70 to 80, okay, which is 10. So it is 10. So you say plus, 10 times, what's the height there? The other one was 30H. This height is 50H. So 10 times 50H. Then we can be able to get. So 10 times 20, this would be 200H plus 15 times 30, this should be 450H, because 15, 30, 45, yeah, 450H plus 5 times 20 is 100H. You can do with your calculator. 5 times 40 is 200H plus 5 times 30 is 150H plus 10 times 50 is 500H. Then I know that the total frequency of my histogram, I know that it should be 160. So I'm going to say 160 is equal to what I'm calculating now. Because I know the total area is the total frequency. Because area is frequency. Don't forget it. Total frequency is the total area. Okay, but I know the total frequency. Okay, so let me say that the total area, total area of histogram is going to be, we know that it will be equal to 160, right? We know that it'll be 160. So 160 is the total area because it's the frequency. The total frequency is the total area. That's the same thing. So I would say now, so area of a histogram is the frequency. Don't ever forget that. So when we say area of histogram, we're just saying total frequency. So we know that. We get 160 is going to be equal to, let's add them, 200H. Let me do that with the calculator. Now I need the calculator help. 200 plus 450 plus 100 plus 200 plus 150 plus 500. I'll get 1,600. So it'll be 1,600 of H. Now, what do? I take 1,600 to the other side. 160 over 1,600. It's now dividing because it was multiplying. This is now equal to H. I'll get 0.1 equal to H. So now I know my H, and that means I can get all the frequency densities, which can help me to find the frequency. So now, how do we get the frequency? Let's just go ahead and make the table. Now, the table is, we are going to have here the weight, okay, because that was the first thing, right? It was the weight in kgs. So yes, we have the weight in kgs. Then I'm going to put next the boundaries, okay? We are going to put the boundaries. Then after putting the boundaries, we can be able to find the width. Then after we find the width, we're going to we can now get the frequency density. This is the interval width, by the way. This is interval width. Then we can be able to get, after interval width, we can get the frequency density. After frequency density, we can now get the frequency. Because you say to me, why did we do this? Because frequency is equal to, here is the formula. Go back to the formula. Frequency, which is what you want, it will be frequency density times the width. What we have just done is so that we can get the frequency density. Then now we can say times the width, we can now get the frequency itself. Don't ever forget that. Why we did this whole H thing was so that we can get the frequency density. Now, if we now know the frequency density, we can be able to get the frequency. So let's now put it. We make our table. So what are the weights? We put the weights. They say continuous, right? Did you see? They say grouped frequency table. Yeah, we know. Let's go ahead. What's the first? It's from 30 to 40, right? So the first would be 30 less than or equal to X. I'm going to put X as my symbol, which is less than 40. Okay, 30 to 40. Then the next one would be 40 to 50, 40 to 55, I'm sorry, 40 to 55. So it's going to be 40 less than or equal to X, which is less than 55. Okay, then what is the next one? It is 55 to 60, 60 to 65, 65 to 70. So it'll be just 555 up to 70. So 55 less than or equal to X, which is less than 60. 60 less than or equal to X, which is less than 70. No, it's 65. Then 65 less than or equal to X, which is less than 70. Then 70 goes to 80. So it will be 70 less than or equal to X, which is less than 80. Now that we have it like that, we can go ahead and put what we need. Let's go ahead and put what we need, right? We can make our columns now. Here are our columns. Right, let's go ahead and let's put everything which we're going to need. Okay, you can draw a better table than me. I know any day you can draw a better table than I can. You can draw a better table. Come on. Right, so I'm just doing a rough draft in order to finish. Now, here we have boundaries. We'll call this lower class boundary. Then we put it like that. Then we'll have the upper class boundary. Okay, now here's the tip. When you do this question where you don't get the vertical scale, you are going to make this table. Now, when you make this table, please do this for me. There are two things that we are actually going to calculate. One is going to be the frequency density, and the other one is going to be the frequency. So I should make their columns a little thicker. So you see, I've tried to make them. Now, these other ones don't matter. They are not going to be calculations there. So here, let's go ahead. Let's put our boundaries. So what are our boundaries? Lower class is 30, upper is 40. Why? Because this is an easy scale. This is a continuous scale. It goes 30 to 40, then starts from 40, goes to 55, then starts at 55, goes to 60, then starts at 60, goes to 65. So where it ends here is where it started there. So that means it's continuous. So I can, the lower bound, I just put it in the upper bound. So 40 would be 40, the upper would be 55. No calculation needed here. Here it's 55, the upper is 60. Then here it is 60, the upper is 65. Then here the lower is 65, the upper is 70. The lower is 70, the upper is 80. What is the width? 40 minus 30, 10. 55 minus 40, 15. 60 minus 55, 5. 65 minus 65, 70 minus 65, 5. 80 minus 70, 10. Here I have the width. Then now I can get the frequency density. What is my frequency density? Now I'll be just going to all the things. Remember now my frequency density. Remember here it was in terms of H. Now I know what H is. H is 0.1. So I can be able to get it. For the first one, it was 20H. So in here, I can say it will be 20 times my H is 0.1, which would give me 2. Then for the next one, what is my frequency density? It was 30H. So I'm going to say it would be 30 times 0.1, which would give me 3. Then for the next one, it was 20 again, 20H. So it would be 20 times my H is 0.1, which gives me 2. So I now know my frequency density. It is actually 2 by finding H, by knowing what H is. Then I go to the next one. On the fourth one, what is the fourth one now? Number 4, 1, 2, 3, 4. The fourth bar is on 40H. So it's going to be 40 by 0.1, which gives 4. Then the fifth one is on 30, sixth one on 50. So it'll be 30 by 0.1. Then here it will be 50 by 0.1. So 30, this gives me 350, this gives me 5. Now, what is frequency? Here it is. It is the frequency density times the width. So I'll be multiplying width times frequency density. I'll get frequency. So 10 times 2, I'll get 20. 15 times 3, I'll get 45. 15, 30, 45. Yes, 5 times 2, 10. 5 times 4, 20. 5 times 3, 15. 10 times 5, 50. So I'll get my total frequency as 50. And this would be my table. Now, just to confirm, I should add them and see if they give me 160, right? All the frequencies. I would say 20, let's go, 20 plus 45 plus 10 plus 20 plus 15 plus 50. 160, it gives me 160. Great, so this is going to be amazing. So this is, if I can write, I can say la summation of F is 160. This is going to be a nice row. There we go, the row of total. So that's what you need and you are done. Okay, you are done with this part. Let's do part 2 in the next question, in the next video, sorry, bye.